Good afternoon. Let me introduce our research work studying the interaction process of a solid particles flow with the hydraulic classifier flowing path. Researchers participated in the study are Andrii Bondarenko, Oleksandr Shustov, Andrii Adamchuk, Dnipro University of Technology, Dnipro, Ukraine. The purpose of the work is a theoretical and experimental study of the process of the accompanying movement of solid particles and the horizontal flow of liquid within the flow path of the hydraulic classifier. The processing of fine-grained materials is traditionally carried out in gravitational apparatus with the horizontal movement of the carrier flow. For example, horizontal classifiers, decimeters, screw classifiers, decanters, horizontal settling tanks, etc. Carried out the research can be useful in the design of horizontal hydraulic classifiers that are used in the delimation and classification of construction, glass, molding sands, enrichment of non-ferrous ores and rare earth metals. Despite the mass nature of the work aimed at studying the process of falling solid particles in a stationary liquid, the process of motion of solid particles relative to a moving horizontal flow of a carrier slurry remains practically unexplored. Unprovenly, consider it that in a carrier horizontal flow, solid particles move with the flow velocity. It is known that the rational size for gravitational processing, for example, quartz particles, is between 0.15 and 5 millimeters. In this case, the separation range for horizontal classifiers can be considered the finenesses of between 0.1 and 0.2 millimeters. Thus, to justify the rational parameters of the apparatus for the gravitational processing of granular materials in a horizontal flow, it is sufficient to simulate the movement of solid particles which have a size within the separation range expected values. The characteristic modes of movement of solid particles in a horizontal slurry flow during hydraulic classification in a horizontal flow can be movement of particles with deceleration relative to the carrier flow at a constant and increasing speed of its movement, movement of particles with acceleration relative to the carrier flow with a decrease in the speed of its movement, movement of particles with the speed of the carrier flow. In this slide is shown a diagram of the process of movement of a solid particle in a horizontal fluid flow, where indicated the formula's components. Force of the hydrodynamic pressure, velocity of the carrier flow, speed of movement of a solid particle relative to the carrier flow, resistance force, strength of Archimedes, gravity. To describe the process of interaction of the horizontal hydraulic classifier flow path with a slurry flow that includes suspended solid particles moving along, we applied the Lagrange method. The horizontal motion of a solid particle is characterized by its mass in a liquid, force of the hydrodynamic pressure at the velocity of the carrier flow, and resistance force at the speed of movement of a solid particles relative to the carrier flow. After transformation, the equation of motion of a solid particle in a horizontal liquid flow will take the form. In this formula are used density of slurry, density of the solid particle, drag coefficient, the solid particle diameter, velocity of the carrier flow, speed of movement of a solid particle relative to the carrier flow. Let us analyze the obtained dependence and consider three modes of motion of a solid particle relative to the carrier flow. Taking into account the associated movement of a solid particle and a carrier flow, which can occur with the relative movement of a solid particle and liquid, the equation of motion given on slide 6 will take the form. Let the solid particle be motionless. In this case, the velocity of the liquid relative to the solid particle is equal to the velocity of the solid particle relative liquid. A graphical representation of this process in the absence of relative motion of the carrier flow and solid particles in the original cut shown in the figure. To construct the trajectory of motion of a solid particle moved by a horizontal carrying flow in the horizontal and vertical directions, formulas are proposed on the slide 9. As the horizontal component of the velocity experimental value of the speed of free fall of a solid particle is proposed to use. Laboratory studies of the interaction process of the horizontal hydraulic classifier flow path with a slurry flow that includes suspended solid particles are performed on the basis of specialized laboratory equipment. Laboratory equipment is based on the use of a horizontal multi-section classifier, HMC. On the slide is shown the trajectory of solid particle moving along the horizontal hydraulic classifier flow path, designed with the formula shown on the slide 9. Processing of the experimental data showed that in the size range less than 0.2 mm, more than 90% of solid particles sedimented in compartments from 2 to 6, located in the theoretical area of sedimentation of rounded quartz particles with a size of 0.2–0.1 mm. An analysis of experimental data from laboratory studies of the movement of rounded quartz particles with a particle size of less than 1.8 mm showed that the influence of the solid concentration in the slurry within from 0 to 20% on the average size of the granular material deposited in the compartments does not go beyond 5%, and the average error is 1.6%. The work results indicate the possibility of applying the obtained theoretical dependence in the design of hydraulic classifiers fed by slurry with solid particles of quartz or minerals of close density in the concentration range of from 0 to 20%. The description of the interaction process of the classifier's flow path with the horizontal flow of the slurry using the Euler equation for an ideal liquid is length. Thank you for your attention for our work.